Hello students. So in this video we are going to continue with the back exercise of chapter 9, Force and Laws of Motion. In my previous video I have done the questions till question number 13 we have done. But remember students, by chance, by mistake I have missed the 11th question. So first I will be doing 11th question and then I will continue with the 14th question. So I will read the 11th question first. Two objects each of mass 1.5 kg are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meter per second before the collision, during which they stick together. What will be the velocity of the combined object after collision? So we have here two objects each of mass 1.5 kg. It means both the objects have equal mass, and so we can write under given m1 is 1.5 kg, m2 is 1.5 kg. Okay. Then we have they are moving in the same straight line but in opposite direction. So they are moving in the same straight line but in opposite direction. It means one's velocity we have to take positive and the velocity of other should be taken as negative. They have given that the velocity of each object is 2.5 meter per second before the collision, during which they stick together. So their masses are equal, even their velocities are having equal magnitude but with opposite directions. So u1 is, this is their initial velocity before collision, before the impact. u1 is 2.5 meter per second and u2 is minus 2.5 meter per second. It is your choice. You can take any one to be positive and the other to be negative. They have also mentioned in the question that after the collision they stick together, or sorry, not after, during the collision they stick together. So what will be the velocity of the combined object after collision? As they stick together during collision, so their final velocities v1 and v2, which we otherwise take for object 1 and object 2, they are equal because they stick together. And let us take each of these values to be equal to v. We can denote these velocities by v. We have to find now v, the combined velocity, the velocity with which these two combined objects move when they collide, when they stick together. Okay, so let us see if any conversion is required. Everything is in the proper, having the similar units, or we can say they have units in the same system, SI units. So we'll use the law of conservation of momentum. According to the law of conservation of momentum, we know total initial momentum is equal to total final momentum, or we can directly mathematically write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now we know v1 v2 they are equal and we have taken each to be equal to v. So we'll put v instead of v1 v2 here in both the terms, and taking v out we get right hand side m1 plus m2 in the bracket into v. Now we have to find v and rest things are known. So we can put the values here. After simplifying here we can get v is equal to m1 u1 plus m2 u2 divided by m1 plus m2. Remember here that u2 should be taken as negative. Don't forget to take this as negative, otherwise the entire numerical will go wrong. After simplification we can easily see v is 0 by 3. So numerator becomes 0 because see this m1 u1 and m2 u2 values, they are equal. But because the directions are opposite, so we are getting they are equal and opposite. So same two terms with negative sign in between, so we get 0 in the numerator. So v is 0 by 3, that is 0 meter per second. Or we can also write it that way, although it is quite similar. Total initial momentum is m1 u1 plus m2 u2. And I have put the values and the answer is 0. According to the law of conservation of momentum, total final momentum is total initial momentum. You can write total final momentum is m1 plus m2 into v, because the two bodies stick together. So, and their velocity will be same, into v is Now what is the initial momentum? We have calculated 0. So m1 plus m2 into v is 0. m1 plus m2 is positive. So obviously v is equal to 0 meter per second. I hope this numerical is clear to you. Okay, but the main thing which you have to remember in this numerical is this negative sign. Rest students don't do the mistakes. They do the mistakes here only. They don't take it negative and hence the sum goes wrong. Otherwise the numerical is very simple. Now 14th question. A bullet of mass 10 gram travelling horizontally with a velocity of 150 meter per second strikes a stationary wooden block and comes to rest in 0.03 second. Calculate the distance of penetration of the bullet into the block. Also calculate magnitude of the force exerted by the wooden block on the bullet. Okay. So here we have a bullet of mass 10 gram. So given bullet, its mass is m is 10 gram. Travelling horizontally with a velocity of 150 meter per second. So initial velocity of the bullet is 150 meter per second. It strikes a stationary wooden block and comes to rest in 0.03 seconds. So bullet comes to rest means its velocity becomes 0 meter per second. In time 0.03 seconds. So this is t. See, in this numerical, we have not taken initial velocity of bullet as 0 meter per second because this is not a case, not a numerical where only bullet and pistol are involved. In fact, they have not mentioned anything about the pistol. We have another object, wooden block. So in this case, u will not be 0, u is 150 meter per second. Okay. Calculate the distance of penetration of the bullet into the block. So let this distance be s. And also we have to find the magnitude of the force exerted by the wooden block on the bullet. It should be on the bullet, not the table. Okay. So magnitude of force exerted by the wooden block on the bullet. Remember, it's not table. So F we have to find out. So let us see to find S first. Now M, U, V, T are given and we can easily see from these given things we can find out the acceleration and also any conversion required. Yes, in M we will convert this gram into kg by dividing it by 1000. Okay. So here to find S, we know it is a case of when the bullet strikes the wooden block. Okay, wooden block is able to stop the bullet. Bullet stops after it penetrates into the block. It means there is a force exerted by bullet on the block as well as by the wooden block on the bullet. Okay, so it is a case of uniformly accelerated motion as constant force is involved. So uniformly accelerated motion, we can use any three equations of motion to find S. But we know that first equation is V is U plus AT. In second and third equation only we have S. In first equation we don't have S. But again either we use second equation or third equation. We know we need A. So I have written here to find S. First we have to find A. No need for you to write this thing. Okay. So you should just remember to find S. First we have to find A. And A is V minus U upon T. Either by definition, change in velocity upon time, or we can say by using first equation of motion, A is V minus U upon T. Now put the values of V, U and T from given and we see that A comes out to be equal to minus 5000 meter per second square. Minus we are getting because it is a case of retardation. Ultimately the bullet stops. So it was having more velocity first, then it stops. So it is a case of retardation, so acceleration is negative. Okay, now we'll find S. So we can use either second equation of motion or third. For second, S is ut plus half at square. We can use t. For third equation of motion, we don't have t, but anyway we can use any equation of motion because we have all the terms values here. So I'll prefer this here. Using the third equation of motion, using v square is u square plus 2as. Put the value of v, 0 square, is 150 square plus 2 into a is minus 5000 into s. Which means that 0 is equal to 150 square. Remember, students forget to do the square here. So 22,500 minus 10,000 s. After this, just look here. Take 10,000 s on the other side, so it becomes positive. 10,000 s is 22,500, and after simplification we get s to be equal to 2.25 meters. Okay, so s we have found. Now, magnitude of force we have to find, exerted by the wooden block on the table. So F, by using Newton's second law of motion, F is ma. M is, now put this value in kg, and A is in meter per second square, but don't forget to put the negative sign there. So after simplifying, we get F is minus 50 Newton. Minus sign is there, so you should write one sentence, although I have not written here. Minus sign means that it is a retarding force, or it acts in the direction opposite to the direction of motion of the bullet. Now they have asked magnitude of force, so magnitude of force will be 50 Newton. You can remove the negative sign from there. I hope the numerical is clear to you. So students, do remember that this is magnitude of force exerted by the wooden block on the bullet. Okay, it is bullet, not the table. I hope again it is clear to you. Now 15th question. An object of mass 1 kg travelling in a straight line with a velocity of 10 meter per second collides with and sticks to a stationary wooden block of mass 5 kg. Then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. Also calculate the velocity of the combined object. So here we have an object of mass 1 kg. We have one object and one wooden block. An object of mass 1 kg is travelling in a straight line with a velocity of 10 meter per second. So given mass m1 is 1 kg and this is moving with velocity, so initial velocity u1 is 10 meter per second. It collides with and sticks to a stationary wooden block of mass 5 kg. So wooden block, mass m2 is 5 kg, and since the block is stationary, so initial velocity u2 is 0 meter per second, as block is initially stationary. What they have given is that this object sticks to a stationary wooden block, then they both move off together in the same straight line. Calculate the total momentum just before the impact and just after the impact. So because they stick together, so their final velocities v1, v2 are equal, and I have taken for convenience each is equal to v. You have to find out total momentum just before the impact. I have denoted it by pi for convenience, otherwise every time I have to write the complete sentence. And total momentum just after the impact, that I have represented by pf, small pf. Okay. Also calculate velocity of the combined object. Velocity of the combined object, that is this object and the wooden block, v, which we have represented by v, is question mark. So we are supposed to find out these three things. So first of all, have a look at given. Any conversion required? No. Everything is in having the SI unit only. So the units are SI, all are in the SI unit, so no need to do any conversion. So let us do this first. Total momentum just before the impact. If this is a total momentum Pi, we'll use a letter now. Pi is equal to, total initial momentum will be initial momentum of this object and the wooden block. So it will be m1 u1 plus m2 u2. Okay, so putting the values 1 into 10 plus 5 into 0, we get 10 into 1 is 10 plus 0. So total initial momentum is, after simplification, 10, and momentum has a unit kg meter per second. So 10 kg meter per second is total initial momentum. See, in this case, in any question, unless they mention, we will always assume that there is no external unbalanced force acting, like frictional force or air resistance is zero. Only if they mention, we are going to consider. So in this case also we'll assume there is no external unbalanced force acting. So to find the total momentum just after the impact, we'll consider according to the law of conservation of momentum, PF, final momentum, total final momentum is equal to total initial momentum. Okay, and even if external force is acting afterwards, they have written total momentum just after the impact, so we can ignore it. So total final momentum is equal to total initial momentum, that Pi we have found just now. So it is same, PF is equal to Pi is same 10 kg meter per second. Lastly, we have to find velocity of the combined object V. How will do that? We know that total final momentum contains the combined velocity V. So we'll write formula for that. Either we can do it directly, m1 plus m2 into V, as we know that V1 and V2 are equal and we have taken each equal to V. Or we can add one more sentence, PF is m1 V1 plus m2 V2, and since V1 V2 are equal to V, so finally we get this only. You can use it directly or show the steps for it. So PF is m1 plus m2 into V. V is equal to PF divided by m1 plus m2. PF is this 10 kg meter per second, m1 is 1 kg and m2 is 5 kg. So after simplification you get V value to be equal to 1.666. Rounding it off to 2 decimal places, it is 1.67 meter per second. I hope the numerical is clear to you, and I hope you have understood all the questions that we have discussed in this video. We'll continue with this back exercise in our next video. Thank you, students.